Okay, so this section is all about essentially undoing the chain rule. Okay, so let's think about this problem right here. So I know that if I ended up with a cosine, that my original equation was sine, right? So if I think about this as sine, and I started with 2x plus 5, okay? So if I think that that is my answer, if I were to check it, and I could check it by taking the derivative, right? We would essentially say that u would be 2x plus 5, and the derivative of u is 2. So if I were to take this derivative and I had sine u, the derivative of that would be cosine u. And remember, we always multiply that by the derivative. So I ended up with cosine of 2x plus 5, and that's multiplied by 2. I'm just going to stick the 2 in the front. Okay, well, does that match what I had? And the answer is no. So what do I need to add to this purple equation to make it be cosine of 2x plus 5 when I take the derivative? And the answer, what we're looking for, is to see what's different. So I had a 2 in the front here. So in order to get rid of that 2, I'm going to think about the opposite of that. So that's going to be 1/2. So now if you were to take the derivative of this, the 1/2 and the 2 would cancel each other out, and you would end up with this for your derivative. So we did a good job. So that process is called trial and error. But what you essentially have to look for in this section is you want to see how the pieces are different from each other. And we're going to get a lot of practice with this, okay? So this theorem is essentially telling us how to complete the reverse of the chain rule, okay? So here are the steps that we're going to follow, and I'm going to help you go through this. So what essentially that you're going to do is you're going to figure out what function is going to be your u, okay? And then you're going to integrate, so take the reverse of a derivative. Now, one of the things that you do need to take into account is when we have our definite integrals, that's our integrals with numbers here, you are going to need to change those numbers. So once you've set up a u, that is going to change these numbers. And I will show you that as well. Okay, so let's go ahead and kick this off with an example, because I think that's the best way to go through these is practice, 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 and practice some more. Okay, so in this case, just like when we were doing the chain rule, you want to see what can you possibly do to make this a little bit simpler. So in this case, I'm going to say my u is going to be 2x plus 1. Okay, so what's the derivative of that? The derivative of that is going to be 2 dx. Okay, so what I want you to notice now is we have a 2, which we have a 2, which is good. And then we also have a dx, which is good, okay? All right, so now I'm going to rewrite my integral with u substituted in. So we're going to say u to the third, okay? So u to the third. Now, 2 and dx is equal to du. So instead of writing the 2 and the dx, I'm now going to write du. Okay, so I'm substituting in the fact that 2 dx equals du. Okay, all right, from here, we're just going to perform our integration. So what do? We look at our exponent and we add 1 to it, which gives me a total of 4. So I'll say 1/4 u to the 4th power plus c. Okay, and now we just resubstitute back in what we had for u. So we say 1/4 2x plus 1 to the 4th power plus c. Okay, and that one's all done. Okay, so next problem. Let's get a little bit more complicated. Okay, so in this case, I'm going to make this be my u. So we're going to say u equals x to the 5th plus 6. And then we're going to take the derivative of that. 5x dx. Okay, so it's kind of reminiscent of us doing the implicit differentiation. Okay. All right, so from there, we're going to, oh, I forgot my 4th. From there, we are going to see what matches up. So in this case, I've got 5x to the 4th. Okay, so x to the 4th, I have that here. And dx, I have that here. Okay, so what am I missing? I'm missing the 5. Okay, so since I'm missing the 5, what that is telling me is that when I set up my integral using u instead of the x's, I need a 1/5 to counteract this 5. Okay, so I need a 1/5. All right, so we're going to say 1/5 u to the 9th du. Okay. So from here, I can go ahead and integrate. So I'm going to add 1, which is going to give me a 10. So we're going to say 1/5 multiplied by 1/10 u to the 10th plus c. So now we can go ahead and simplify this, and then we're going to replug back in our u. So we're going to say 1/50th, because 5 times 10, x to the 5th plus 6 to the 9th power plus c. Okay. All right, let's do another one, and let's do a trig one. And remember, the cool thing about this, you can always check these by taking the derivative, and you should get back what you started. So if you don't, then you know that you made a mistake somewhere. Okay, so this one. All right, in this case, I'm going to say that u is going to represent cosine x. And I am going to say that du is negative sine x dx. Okay, so then we need to see, can we match? So we have dx, right? Good. We have sine x, good. What's different? The negative. Okay, so essentially what I'm going to do is I'm going to say that this right here I can rewrite as u to the 3rd, and then this piece right here is essentially equal to negative du, because I have that part right here. The only difference is the negative sign. So negative du. Okay. All right, so let's just move the negative out in front just to make our life a little bit better. So we're going to say u cubed du. All right, so then let's go ahead and take care of this integration. So we're going to add 1 So it's going to give me 4. So we're going to say negative 1/4 u to the 4th plus c. All right, so now we can just go ahead and plug in. So negative 1/4 cosine to the 4th x plus c. All right. So let's look at this next example. And we're actually going to do this next example in 2 different ways. Okay. So we're going to have an option 1 and an option 2. This is just going to show you that there are multiple ways that this can happen and work. Okay, so for option 1, I am going to let u be x plus 1, which would mean du is 1 dx. Okay, you don't really need to write the 1, but I'm doing it in this case. So that shows me that I'm going to end up having in the numerator here, that's an x, and I need to get rid of my x's and put u's. So if I look at this first equation here, if I subtract the 1 over, then u minus 1 is equal to x, right? So I can say that my numerator is equal to u minus 1. And again, I'm getting that because I have an x here. I can subtract the 1 over there, all right? All over the square root of u. Du. Okay? All right, so from here, the easiest way to do this problem would be to split up your fractions. So you could say u over the square root of u minus 1 over the square root of u. Okay? So I'm going to simplify this down, and each of these needs a du after it. Famous for not writing. So this is essentially u to the 1/2, and it would be negative because this is in the denominator. So if I add that with this u to the 1, that is going to end up giving me u to the 1/2. And this right here is going to be the subtraction. Oh, I'll write to you real quick. Subtraction of, this is u to the negative 1/2. I'm going to bring that up. Okay. So then, man, my cat's snoring pretty loud. I don't think you can hear her though. She's kind of far away. So then, let's go ahead and integrate this. So we're going to add 1 to each of these. Okay. So that's going to end up giving me 3 over 2. So essentially, we would be doing 1 divided by 3 over 2. And 1 divided by 3 over 2 is going to give me 2/3. So it's pretty much the opposite fraction as what's in the exponent. Okay. Other side. So we're adding 1 plus negative 1/2, which is going to give me a positive 1/2. And essentially, I would be doing 1 divided by positive 1/2, which is going to give me, oh, I shouldn't have written it there. I should have written it further up. So that's going to give me minus 2 u to the 1/2 plus c. Okay. All right. From there, let's just go ahead and plug everything back in that we have for the u. So we're going to end up with our final answer as 2/3 u was x plus 1 to the 3/2 minus 2 times x plus 1 to the 1/2 plus c. Okay, so that's my final answer. Let me just highlight that so we know. Beep, 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 beep. Okay. All right, so guess what? We're going to do it with option 2 now, just to show you that there is more than one way to figure problems out. That's kind of the cool thing about math. I think that's the thing that stresses you guys out a little bit, because you're like, just, give me the map with the exact directions. No detours, no construction. Okay, so in this case, I'm going to say u is going to represent the square root of x plus 1. So just for fun, let me write a few more things down. So u squared then would be x plus 1, straight up, right? Then also, you could think about this. Since I've got x in the numerator, I could say that x is equal to u squared minus 1. Okay. And the other thing that I want to write down is the fact that dx would be 2u du. Okay. So now what we can do is we can go ahead and substitute this in. So we're going to integrate, and the numerator is x, and x represents u squared plus 1. Or sorry, u squared minus 1. All divided by, we had the square root of x plus 1 is my u. And the derivative of x, dx, is 2u du. So we're going to say 2u du. All right, now something cool happens before I integrate. The u is going to go away. And actually, I can bring the 2 in front outside of my integral, so I don't have to deal with it right away. Okay, so let me scroll down. Okay, so now I have 2 u squared minus 1 du. Okay, so let's go ahead and integrate this. So we have 2 on the outside. So we're going to add 1 here, which is going to give me 3. So I'm going to say 1/3 u to the 3rd minus 1 u plus c. Okay, so now what I can do is I can distribute the 2. So I'm going to end up with 2/3 u to the 3rd minus 2u plus c. All right, and then from there, I can resubstitute back in my u. So my u was the square root of x plus 1, right? So if this is already a cubed, and then I have a square root, essentially what's going to happen is the 3 is going to go at the top in my rational exponent, and the 2 is going to go in the denominator, and that's going to represent the square root part. So we're going to say 2/3 x plus 1 to the 3/2. So the exponent part stays at the top. This comes from that square root. All right, and that's going to be minus 2 x plus 1 to the 1/2 plus c. Now you'll notice that's exactly the same thing that we got the first way we did it. Okay, so that's really interesting. Okay, so this next part is talking about how we are using our u substitution, but when we use u substitution, that is going to change the integral bounds, okay? So it's super easy to do. You're just going to plug in to get the new value, all right? So something that I want you to keep in mind with this is when we change u, we change the bounds for integration. Okay, so let's go ahead and do an example. Okay, so this problem. In this case, I'm going to say that u is going to be x plus 3. So then du is 1 dx. Okay, so then the question that you ask yourself is you make sure everything everything that you have is still there. So I've got a dx. This is good to go. All right, now this is the part that I was talking about, the change. So right now my bounds are 0 to 2 for x. So what you're going to do to figure out the u match to that, you're going to say 0 plus 3, which is going to give you 3. And you're going to say 2 plus 3, which is going to give you 5. So your new bounds with the u are going to be 3 and 5. Okay? So dx is equal to du. So we're going to say du is at the top. And at the bottom here, I'm going to have u to the third. Okay, so I don't know about you, but I really dislike fractions. So I'm going to rewrite this as 3 to the 5th, u to the negative third power du. Okay, so we add 1. And so that's going to give me negative 2. So we're going to say negative 1/2 u to the negative 2 du. So from here, now that we've changed these to be u, we don't have to resubstitute in what u was. We are just going to simply plug in the 5 and plug in the 3 and subtract those two values. So we're going to say negative 1/2 5 to the negative 2 minus negative 1/2 3 to the negative 2. Okay, so if you plug all that into your calculator, I left mine in fraction form. I got 8 over 225. Okay, all right, so let's do another one. Okay, so in this case, I want you to be x to the third plus 2, which means du is going to be 3x squared dx. Okay, so let's make sure that I have everything that I need in this one. Do you see the problem here? So we have an x squared. That's good. And we have the dx. That's good. But what am I missing? I'm missing the 3. Okay, so essentially what I could think about doing is I could divide it over here. So I would have 1/3 du equals x squared dx. So that's another way that you can think about these problems, is how can you make them match? And this is what I have. And so what do I need to do to get the du side to match? I have to do 1/3. Okay, so before I keep going, we are going to plug in to x the negative 1, and so negative 1 to the third power plus 2. That is going to give me 1. And then we have 2 cubed plus 2, and that's going to give me 10. Okay, so let's write all this down. We have 1 and 10, 1/3 u du divided by u to the third. Okay, so let me just make sure that you have this. So 1/3 came into play because when I took the derivative of u, I got 3x squared, and I didn't have a 3 at all here. Okay, so I need 1/3 to cancel out that 3. So we have x squared and dx, and what does that equal? It equals 1/3 du. All right, now just like before, I'm going to go ahead and bring my, actually, let's put the 1/3 on the outside. I'm going to bring my u to the negative third up, du. So we're going to integrate. So plus 1. So we're going to get 1/3 times negative 1/2 u to the negative 2 du plus c. Nope, don't need c. All right, so let me clean this up before we substitute. So we're going to get negative, come on, negative 1/6 u to the negative 2 du. And we are evaluating that at 1 and 10. So we're going to plug in the 10 first, and we're going to subtract the 1 value. So negative 1/6, 10 to the negative 2 minus oh, and you know what? Once we integrate, we don't need to write du, and I wrote it again. And that would be confusing because then I would think, oh, I got to integrate this still. Okay, so now negative 1/6 1 to negative 2. All right, now I'm back on track. Okay, so if I plug that all into the calculator, you are going to get 33 over 200 or 0.165. Okay. All right. One more. And then we're going to learn about a special rule. Okay, so in this case, we are going to say that u is going to be sine x. So du is cosine x dx. All right, so do I have a cosine x dx? And the answer is yes. Good. Thank you. All right, so now the other thing that we want to take into account is the bounds. So we need to substitute in sine of 0, which is 0, and sine of pi over 2, which is 1. Okay, so let's write this. 0, 1, u to the 4th du. Okay, so add 1, so we get u to the 5th. So we say 1/5 u to the 5th. Okay, from there we are substituting in 0 and 1. So we're going to say 1/5 times 1 to the 5th minus 1/5 0 to the 5th. And you will end up with 1/5. Bam, bam, bam. Okay, so the next thing that we're going to talk about is we have a special case that we're going to learn. Okay, so there are identities that are going to help us with this problem. Yay, identities. Okay, so making our life easier. All right, so we have two different identities, one for sine squared theta and one for cosine squared theta. Okay, so we are actually going to do the last problem that was up on the screen using this. Okay, so we have cosine squared theta. So cosine squared theta is actually the same as 1 plus cosine 2 theta all divided by 2. So what we can do is we can resubstitute in, so I'm leaving this as 0 and pi over 2. And I'm going to rewrite cosine squared theta as 1 plus cosine 2 theta divided by 2 d theta. Okay, so from here, what I can do is I can actually split up my fraction. So I could say that. All right, so probably the easiest thing to do would be to factor out the 1/2 from each of these. Okay, so now that we're here, let's go ahead and integrate this. So I'm going to end up with doing substitution for this second part right here, because essentially u is going to be 2 theta and du is going to be 2 d theta. So I wrote that wrong. This is du. Okay, there we go. So if you're looking here, we have the d theta part, but we don't have the 2. So, and this 2 doesn't count, okay, because that 2 is up there. So how can I make them be the same? Essentially what I could do is I could divide by 2. So I would say 1/2 du is the same as d theta. So that's what I'm actually going to end up subbing in. And we are going to rewrite now. So I'm going to say 1/2. Integrating d theta is going to give me theta plus this 1/2. Okay, so this one actually, let me write this down first, because we have 1/2 and then we have 1/2 du. So we're going to say cosine u du. I need to put in this 1/2 because this 1/2 is not taking care of it. Okay, so we have 1/2 times 1/2, which is going to be 1/4. And then the integration of cosine is going to be sine of 2 theta. And then from there, what we're going to do is we are going to substitute in 0 and pi over 2. So in total, we're going to have 1/2 pi over 2 plus 1/4 sine 2 times pi over 2 minus 1/2 times 0 sine of 2 times 0. Okay, so then let's think about what all these things equal. So this is going to give me pi over 4 This is essentially the sign of pi. And what's the sign of pi? Look at your unit circle, it's going to be 0. 1/2 times 0 is going to be 0. And 2 times 0 is sine of 0. And what's the sign of 0? It's 0. So our final answer for this is pi over 4. Okay, so there's one more example on here, and I actually want you to try this one. I'm going to give you the answer as 1/3. Okay, so I want you to do this one, and the answer is 1/3. I want you to try that, okay? And if you get stuck, you know what to do. You have to talk to me. All right.